Hi, hello everyone. Today I am explaining about the SRAM cell, means static random access memory cell. In this example, I am considering the 60 SRAM cell. A consistor of the 6 transistor M1, M2, M3, M4, M5 and M6. In this example, in the considering the memory cell as a M1, M2, M3, M4, it is also represented in the form of the using the inverter. One inverter output is connected to another inverter input. Their output is connected to another input of the inverter. Therefore, we give input 1 to the inverter, then output will be 0. This output of the inverter is give connection to the next inverter input, then output will become 1. Then it goes in the circular motion. Therefore, it's storing some as value. It is called as a memory. Then it is output will be a q, and the corresponding output will be q bar. Then connected NMOS to in both side to access the information. Where NMOS will be on when input will be a 1, then NMOS will be a on, then read and write operation will be possible. Then word length will be a 0. There is no case of the read and write operation. Therefore, it is in the old state. Old state. Bit and bit bar lines is considered as a both read and write operation. In write operation, bit and bit bar value as acts as a input. Then read operation, bit and bit bar value acts as a output lines. Then considering a capacitor, it is as a pre-charged capacitor. It holds the voltage of VDD. It is the structure of the SRAM cell. Then go for the read operation. Considering the read operation, in this read operation, memory having some value, we assume q equal to 1. Then q bar will be a 0. Here output will be 1. Then q bar will 0. Then WL means word length will be 1 to access the bit and bit bar values. Here bit and bit bar acts as a output in the read operation. Then capacitor is a pre-charged capacitor. Therefore it is a voltage VDD. Then here compare Q and bit line. It is no voltage difference between them. So there is no chance of the current flow in this region. In this q bar equal to 0, then VDD will be 1. Then it is a voltage difference between them. In this case, it is a possible to current flow in in this manner. So it will voltage is discharges randomly through the M4. Then bit bar where voltage will be decreases. And considering a sense amplifier, it acts as a comparator. It compares the both bit bar value and bit value. Then bit bar value is decreases. Then output will be become a 1. In another case, considering the assume q equal to 0, then q bar will become 1. When it is 0, q bar will 1. In Q bar and bit bar lane, there is no voltage difference between them. So it is no chance of the current flow in this region. And considering the bit and Q value, there is a voltage difference here. Therefore, the voltage discharges in through the M2, then bit values decreases randomly. Then considering a sense amplifier, it compares bit and bit bar value. Then bit value decreases, then output will be 0. This is the read operation. And next we go for the write operation. In assume q equal to 0, q bar equal 1, then WL will always 1 because to access the information of bit and bit bar value. Then bit and bit bar value, bit bar acts as a input. Then considering q bar equal to 1, q equal to 0 here, you're comparing VDD and q bar will no voltage difference between them. That's why forcibly connected bit bar to the ground, then it will be bit bar become 0, then q bar will be 1. This discharges slowly to the ground, then finally q bar will get to 0. Then this output is connected to another inverter as a input. Therefore, if the M1 is as a PMOS and M2 will be a NMOS. Therefore, M2 will be a off in their logic 0, then M1 will be a on for logic 0. Therefore, M2 will act as a open circuit. Then VDD suppressed through the M1 will get output Q equal to 1. Therefore, first we assume the Q equal to 0, then we get Q equal to 1. Therefore, it changes, then it write some value into the memory. This is called the write operation. Thank you.